Hello everyone. So this is our presentation for our project on the RTSP protocol. So before beginning with the implementation and the working of the final project, we'll just like to give you a brief overview. So RTSP is specially designed for multimedia communication between client and server. The real-time streaming protocol, that is RTSP, is a control protocol designed to add more functionalities to the streaming process of multimedia. Using RTSP, we can control the playing of audio or video. RTSP is an out-of-band control protocol that is similar to the second connection in FTP. RTSP has mainly four kinds of request types. These four methods or request types are setup, play, pause, and teardown. So now let's look at the working of this. The HTTP client accesses the web server using a GET message. The information about the meta file comes in the response from the server. The meta file is passed to the media player. The media player sends a setup message to create a connection with the media server. The media server responds. The media player sends a play message to start playing or downloading. The audio video file is downloaded using another protocol that runs over UDP. The connection is broken using the tear down message, which happens at the end of the usage of the player, like after multiple play and pause requests. When the user finally closes the video, a tear down request is sent to the media server and the media server responds to it, and the media player can send other types of messages as well. So we are having 6 files: the client py, the client launcher, the RTP packet, the server worker, and video stream. In the client file, we have a function named send RTSP request. In this function, we first check the kind of request we want to send. If the request type is setup and the client is in init state, here as we can see the request type is setup, and if the client is in init state, then we increase the RTSP sequence number by 1, and we also start running a new thread to receive an RTSP request. We also keep a track of the last request sent by client to the server in the request sent variable. Okay, and after that, if the request type is play and the state is ready for the client, then also we will increase the RTSP sequence number by 1, and we also update the last request as play. Here we update the last request as play. If the request type is pause and the client is in playing state, as you can see here, then also we increase the RTSP sequence number by 1. This extra part of code which is present in just every this extra part of code which is present in just every if else if segment is used as an output on the terminal for the ongoing process. So for example, if the current request is pause, then this pause string is displayed on the output along with the file name and this string, which shows that it is the RTSP 1.0 protocol, along with the C sequence number and the session number. And similarly, if the request type is tear down, here if the request type is tear down and the state of the client is in it, then also we increase the RTSP sequence number and keep a track of the last request sent as tear down. Now before sending the RTSP request, we encode the data in the UTF-8 format. This is a standard encoding format, and we use this to encode the data before sending the RTSP request. Now coming to the receive RTSP reply function. In the receive RTSP reply function, we are receiving the reply of the RTSP request sent from the client to the server. We will process this reply and decode the UTF-8 format with which we had previously encoded. We will check if we have sent a teardown request to the server. If yes, then we will close the RTSP socket. As we can see here, we shut down and then we close the RTSP socket, and this is in the case if we have sent the teardown request. Now coming to the parse RTSP reply, which processes the RTSP reply. In the parse RTSP function, we are extracting the sequence number. Here, as we can see, it is stored in the secnum variable, and we extract the sequence number of the past RTSP request. If the sequence number is same as received from the server side uh, to the sequence number which we have sent, then we will store the session ID in a variable named session ID, and this is done if and only if the session ID is 0. Now if the session ID is same at both the server and the client side, then we will change the state to the current state. So as we can see, we are if the session ID at both the client and the server are same, then we change the current state to the, so basically we change the state to the current state which is ready here, as we can see, and we change the request to the current request which is setup request. Okay, and if the request type is setup, as we can see here, if the request type is setup, then then we will create an RTP port to receive data from the server. As we can see here, the open RTP port is used to receive data from the server. Similarly, in the open RTP function, before jumping there, here are the other request types and the states, and we just update the current state and the request type based on what we have received. So coming to the open RTP function, we are creating a RTP socket at the client side, and we will bind the test socket to the, as we can see here, the socket is being created at the client side, and we will bind this socket to the RTP port. As we can see here, this is the RTP port, and we bind this socket to the RTP port which we have given as the argument first. So I think this explains pretty much of the part which was to be done from our end. So now let's look at the implementation of this code. So yeah, let me run this code. Python 3, then we give the file name server.py, and then we as we know that the ports till 1023 are occupied for some specific processes, we can use any of the port above 1023. So we are currently using the port 1030. Okay, so this serves as the client terminal for us. So yeah, we have executed the command, and now we will open the so sorry, I'm caused a mistake. This would serve as the server side of the terminal. This would serve as the server, and now we will be writing the client side in this terminal. So for using the client, we'll type the code Python 3, the file name client launcher dot py, then the local IP address 127.0.0.1. Then we will use the server port number, that is 1030, as we had mentioned in the server terminal, and then we will write the RTP port number, that is 10500, and lastly we will write the file name which is movie.mpeg, and as we would run this command, so mjpg and as we run this command, this GUI box will pop up. So if we so before run using GUI box, yeah, so this is the server part, and when we use the setup button, this setup request is sent to the server by the client, as you can see here. And now we will start the video by pressing the play button. As we can see here, the video has started to play, and if we look at the client the client terminal, it is currently receiving the sequence numbers for the video. Now if we pause this, the movie has been paused and the client has stopped receiving the sequence numbers. Now if we again play the movie, the sequence numbers have resumed and we again pause this. Okay, and at the end, if we want to close this video, we will use the tear down command. So after we tear down, the tear down request is sent to the server. So in this server, the data received, as you can see, tear down. Okay, and here we can see all the commands which we have sent. We first played the, after setup we played the video, then we paused, then we again played, then we again paused, and lastly we teared down. So this is how the RTSP protocol works, and thank you for listening to our presentation.